in ops, we're trying to manage this environment. We are not doing the things that we really want to, that we know is important for protecting and defending our environment. And I used to joke around. I defended systems by burying them in paperwork and Excel spreadsheets. So how do we deal with this? I can't get rid of this stuff. So tactical SecOps is some ideas on how to deal with these obstacles that we have that we can't get away from. I want to try and increase my visibility into my network, making sure I'm seeing what's actually there. Now, to do this, this is going to require some time. This is going to require some automation. We want to automate as much as possible to get rid of the mundane tasks or regular things that can be, easily scheduled up, but that we tend to forget about because they don't scream at us and say, hey, it's time to run the port scan of prod environment and see what's there. So in this presentation, what we're really looking at or interested in is, oops, I jumped ahead. We'll get to this a little bit later. But we get into our environment, or we're sitting out here working, and somebody walks by and says, hey, did you know about this? And, how often you find yourself sitting here kind of with this expression on your face. Utter shock is, you find that somebody pushed out an entire environment on you, and you had no idea that it was there. They didn't bother to mention it. You didn't see a change request. One of my favorites was finding a web application that somebody had deployed inside of an overall site that had decryption keys in it and would decrypt some of our configuration data, and that was exposed to a much broader audience than expected. And this is how I found myself looking. I about had a heart attack at that point. So as we're going along, we find things like, like I said, new hosts, new applications are showing up in our environment. Sometimes whole new testing environments or QA environments, application development. It used to be if somebody wanted to deploy another 30 servers, I got a pretty good sign that something was going on because we had stacks of server boxes sitting around as they were getting ready to rack and deploy these systems. Well, now, with virtualization being as common as it is, that doesn't happen at all. You rarely see that happen at all. Occasionally a new box comes in to do some purpose, but for the most part, you can deploy 20, 30, 50, 100, however many systems at the drop of a hat, and you don't necessarily find out about it. Another favorite of mine is you're going along and you had found a flaw and it got fixed and you tested it, and then all of a sudden it comes back, and that's another thing that pops up. Or systems that are configured badly. Things like default credentials still being enabled on a box. Appliances are really good for stuff like that that we find during our testing. And as I sat here looking at this and thinking about this, there's just no end to what can go wrong on us that we can discover and surprise the heck out of us. So we've got Inigo Montoya's famous line here: "No, there's too much. Let me sum up." We just want to be able to cast as wide a net as possible so we can see that these changes or these things popping up in our environment as soon as possible. So where are we going to start? We have to figure out some way to discover what's inside of our environment. I really like this quote by Richard Bailick. You first have to figure out what you're defending. You get dropped into a network or into a company, you're going to find some documentation either in Visios or a wiki somewhere, some spreadsheets, maybe you've got an IP database. It's going to be spread all over the place. And probably it's going to be out of date. You're not going to have things, you look at the modified date on the file, and it was a year ago. Okay, what's changed since then? Oh, well, we changed the whole network architecture over here, and it looks entirely different now. So that's not really helping us out very much. How many applications do we have in our environment? Does anybody really know it all? I mean, as you look at it, how many web apps are floating around out there? What is our environment? Are we using cloud computing? Are we using AWS? Are we using Rackspace or some other cloud provider? We have to try and figure this out and get ahead of this. And as you look at this, sometimes some of the things that I would get when you start talking to folks about, well, you need to let me know ahead of time that this is coming. Some folks would throw back and say, well, we've got change management. You can see that we're going to deploy this system or this app. The problem is if I'm trying to secure the app, if I'm trying to get things ready, if it shows up into a change request at the day before or the week before this change is going live, it's probably too late to do very much that's meaningful. So we're going to be stuck. And, quite frankly, as we're running around doing, handling the drive-bys and the emails that pop up and meeting requests or whatever, some of this stuff slips by. So we need to have some ways of catching these new things arriving in our, showing up in our networks. So one of the first things that we always tell people when we're talking about some of these little surprises and bits of treasure we find during penetration tests that the ops guys had no idea was there. One is to inventory as much as possible. And I don't necessarily mean inventory like sitting there with a spreadsheet going through, line by line trying to create an inventory. Though I think that would be good to have and update, either get it into a database or something or other so we can have one place to pull all this information. But we're going to want to collect, hey, what are our systems out here? What are our applications? What types of environments are this for these applications? What's in Rackspace that we have hosted for us? And the reason why I tell people to do it as often as possible is you come walking in one day and you glance at your ESX infrastructure and all of a sudden another 10 systems are online. You didn't know they were there at all. Now we've got a couple of different ways of doing this discovery. We've got passive discovery and active discovery. Passive discovery is what I term as things that we're not actually out touching the individual systems or interacting with them. Really what we're probably doing is running some kind of tap or span port on our networking equipment and monitoring the traffic as it goes through and seeing what shows up. PADS is a great system for that. Sits there and just quietly monitors what's going on and records, hey, I saw this new device, I saw this new app, and saves it off to a file for us to take a look at. So what we'd recommend doing is you set something up like this, you're going to collect a lot of information this way. It's actually going to be a little bit overwhelming. So what you would do is set it up, let it run for a few days, and then go in and look through that data and see what you have, see what you can consolidate down and find out, okay, what, do I have workstations out in there running Firefox 10? Or something super ancient? Do I have devices that I didn't even know were there? All of a sudden I see some kind of wireless access point that's not authorized. Maybe making a request to across the network. We can see that. We want to look at things like session data. We've got tools like NetFlow on our networking equipment, or you can use an application called Argus that does the same thing. Argus at least does the same thing as PADS. It sits there and just listens on a tap or a span port and collects who's talking to who. And you can start gathering a lot of information from that. You can start to see things like, is it common for host A to talk to host B? Well, yes, it is. But they usually do that during business hours, and then things go very silent. Or there's a batch that fires off over the weekends, and it gets very busy between these two hosts, and then it tails off, and there's not as much going on. And so we get a picture of, hey, who's talking to who? What's the ebb and flow of that information? Is there anything in here that's new or unusual? We can capture network data, full packet captures, take that information. You probably would want to do that on a rather select basis, but go ahead, load that up into Wireshark or Network Miner or other tools and do some analysis. Now I have Security Onion here on the bottom. We're going to take a look at that here in a bit. But the reason why I mention it is it has all of these tools really ready to go for you, installed on a Linux distribution without having to go and compile all the dependencies, etc., and get that taken care of. So we can just set up a Security Onion box and get to work without spending a lot of time playing sysadmin. Now, previous to Secure Ideas, I came from working at Tenable. We would always talk about doing scanning to discover hosts inside of our environment. And that made sense. I mean, Tenable produces Nessus and Security Center, and they actually have passive methods of finding systems and applications and things like that. But really, when you stop and think about it, with everything being centralized into virtualized systems or cloud providers, it starts to make a lot of sense of, hey, let's just query our ESX hosts for what they have. Let's just query AWS and tell me what systems I have out there. What are their names? What are their IP addresses? What security configurations have been applied to them? And throughout here, you're going to hear me talking up automation and scripting. And personally, I use Python for a lot of my scripting. I started out really working with Perl a number of years ago, but everybody jokes around about Perl being a write once language, and then read never. We write up a script, we get it working, we leave it alone. Python is just so much easier to work with and see what's going on and knock things out quickly. Now, there's a pretty cool module for interacting with your ESX hosts. It's got the link here, googlecode.com/p/pysphere. You can do something like this really easy. Here's a quick script. Hit some ESX host or your virtual center host, give it your username and password, and tell it, hey, get me the registered VMs. And then from that, I can start printing out different properties. Or, in this case, this is a simple little script just meant to print it out on the screen. I can take that information, push it into a database somewhere. I can format a report and send that off. Really, it's what you want to do from here. But you see how simple and easy this is. We just declare, hey, we're going to import our PySphere module, connect to the server. Here's our credentials. Give me the registered VMs, and now I just iterate through and get the extract out the different bits of information that I want to use. So I would look at spending some time here, look at what you have and try to find out where you have things hosted at. Maybe somebody has slipped by you and set up something at AWS and not mentioned that. But start querying those repositories of information because they've just got a ton of information there about what we're actually running. And then we can start digging in deeper from there. Even if we have things hosted out there, we've pulled back, hosted in virtualization, we've pulled back the application or the hosts, information about their network configuration and such, but we still don't really know what's running on them, what applications are deployed on it. And if I want to go out and on a regular basis see what's happening in my environment, Nmap is a great way to go for that. In fact, I was talking to somebody just the other day about different scanning and needs that they had, and we were discussing some of the costs associated with running scanners. Some of the, depending on which application or vulnerability scanner you're using, some of them hit you differently for IP counts and or how many scanners you're going to deploy. So Nmap, that's free. We don't have to deal with that. We can push that out to as many different scanners as we want and automate that, run it, grab those results, and do something with it. We want to try to scan as near as possible to our targets. And the reason why we want to do that is, you get some kind of next-gen firewall or something like that sitting in between you and your scanner and your target systems, and you start to get odd results. Things aren't coming out quite right. And it's really easy to just go ahead and set up a system out there that has access close to the systems, our targets, and light it off and see what we find. And we'll talk about the vulnerability scanners a bit later, but those applications like OpenVAS, Nessus, Nexpose, Retina, etc., all can do this as well. But let's take a look at Nmap in particular for this and some ways we can use this maybe a little differently than we currently do. So depending on your network, I may approach scanning, very differently. We get into some environments where we're testing and we've got 10 Class Cs to go through. Well, that's not too bad. A few thousand, 2,500 hosts or so. We can get through that in pretty short order. So I can just fire off a few Nmap scans, have it be pretty thorough on each scan, do reverse DNS lookups to get me information out of the environment as to what the name of that system is, maybe give me some hints as to its function. But you may find you're working in an EDU, and congratulations, you have a Class B. You've got 65,535 hosts to go scan down, and that is going to take forever if you set up one single scan to run. So instead, set up some discovery scans. We're running some ping sweeps. And I say ping here because that's generally what the documentation calls it. But Nmap will do things like, yes, it'll do ICMP, but then it'll also check some common TCP ports and see, hey, do I get a response back on these? Port 80, 443, things like that. Did anything respond back? Maybe didn't respond back to ICMP, but we got an HTTP response. So, okay, great. There's something there. But the point is it can run really fast and get through this in these broad stretches of addresses. We can see what we've discovered and then take that information and start to get into more detail. At this point, we could start looking at doing service detection scans and operating system detection scans. You do want to be a little careful with this, though. You want to be aware of what your environment is and how delicate maybe some of these systems are. For the most part, it's probably not going to be an issue, but I know talking to a friend of mine named Justin Searle, he does a lot of testing for SCADA systems, and he'll tell you that a service detection scan in Nmap will start knocking over SCADA systems. They're just really fragile. I talked to another guy once that had this ancient operating system running out there, running some old application that the company that made it no longer exists, but they have to maintain it. They couldn't replace it, and it was extremely critical to their business. So you want to know about that before you light something off at it and potentially cause it to fall over. Printers, for example, can be fragile or can do things like spit out a ream of paper if you tell it to go after the printer ports. Just when I start to think that I've seen really what, pretty good snapshot of what the fragile systems are out there, it seems like I find others that I had no idea of. And so, who knows what else we can bump into that will fall over and then our phone starts ringing with some extremely agitated and upset person on the other end of the line. When we do our scans, what we want to do is run this often. And I say daily, if possible. And if with an Nmap, we can split this out into multiple scanners, we should be able to do this even in really large environments. But try and scan daily, because we just don't know what's going to pop up in that environment from one day to the next. We want to flag anything that's new, be it a new system or a new application. And I look at a new application kind of as just it's a new IP address, maybe not. Maybe it's an existing IP address and a new port that we hadn't detected before. And when we see something that's new, that's a flag to us. Hey, I didn't know about that. That just arrived there. It's unexpected. Let me dig into that and see what it is. Or, hey, I was involved in this project. I knew that this was the go live date. Sure enough, it's there. Great. We had done all of our testing before, but let me go back and do some testing now that it's live and make sure that things are working right there, that our defenses are actually up and performing as expected. Now, if you're going through all of this, you're going to find you have a lot of data to deal with, and you're probably going to start finding a lot of surprises inside of that data. One thing about Nmap is that it is spitting things out to the screen. And we can tell it to go ahead and write to a few different file types, .nmap file, which basically looks like what shows up on standard out on your screen, gnmap, greppable nmap format, or an XML. So I can go ahead and schedule a scan to run maybe at 2 a.m. in my scanning window, but then come back and catch my results later in these files. But as we're getting a bunch of these files, we now have to start making sense of this data. So we're going to take a look here at an app called PBNJ, which is Ports, Banners, and Junk, written by Josh Abraham, or Jabra. I may say it uses Nmap heavily here. It's a wrapper around Nmap, at least its scanning portion. The cool thing about this is we can distribute out our scanning easily, but still centralize our collection of data. So if I'm going to run PBNJ, say I've got a scanner up there, the output for it is just scan PBNJ minus A for our arguments, and then we put in all of our arguments for Nmap. And then tell it our target range that we're going to go after. This is where I would put in things like, in this example, yes, we're going to do some service detection and interrogation. We're going to try and determine the operating system. I want to scan all 65,535 ports. Do I want to write it out to a file or not? Maybe I do, maybe I don't. We'll take a look at why that is here in just a moment on one of our boxes. As you can see here, we're running this scan. It's inserting this information into a database as it runs. So that allows us to, have this central repository of stuff instead of digging through individual files and trying to compare, this week's file to last week's file. Now, if I was going to deploy this inside of a large environment, I probably would not deploy PBNJ out there all over the place. What I would look at doing is centralizing that, having that run in one spot, and have all of my Nmap hosts pointing back to that system. Have them SCP those files over. Then I can have another job that picks those files up and does the actual import and loads them up into the database. So I would look at it from that idea. Let me push as many scanners out there as possible that make sense. for my network, and have them be able to get back to the central box and load up the information there. Now, like I said, we can use PBNJ to insert directly into the database, or we can tell it we use Nmap and we tell it, hey, write the results out as XML, and all you do then is run scan PBNJ-X, your results file, and away you go. So let's take a look at PBNJ in detail here. Okay, you should see the whole screen now. Okay, is my Kali instance showing up properly? Perfect. So if you want to install PBNJ, it is a Perl app, and it has a number of Perl modules that it wants to pull down, which can be a real headache. So I cheated. I went out and just used Kali. It's not, PBNJ is not part of the default installation of Kali, but it's part of the repository. So installing it is as simple as apt-get install and PBNJ. Now I've already done that on this system, and have it pretty much set up. Oops. All right. When we get PBNJ installed, it creates this directory, .pbnj- whatever the version number is. And this app doesn't change very much. I think version 2 has been out now for a couple of years. So, but if I go into .pbnj, if I could type, we've got 2 configuration files to work with, and they're just YAML files. How am I going to set up this instance? What kind of database am I going to push this to? So all of that is contained inside of config.yaml. Scroll down a bit here. Now, how visible is the text from you guys' perspective? Is it legible? Okay, good deal. We really just have a few options. Okay, some folks not really, some folks yes. Okay, I'll just try and read through this a bit. We've got a few options here. First one is just DB. What type of database are we going to use? We have an option of picking SQLite, MySQL, or Postgres. Any of those will work. I left this as SQLite for right now for the purposes of this webinar. If I was running this in a production environment, then I'd be looking at pushing it over to MySQL or Postgres, whatever is acceptable to my environment. If I'm using something like Postgres, then I need to set in some credentials. So username, password, what's the IP address of the system, and what port is this going to be going to. And that's really it. We've configured PBNJ at this point to pump all of its data into our target database. Now, like I said, I've left this as a SQLite DB. So that's what we'll use today. There's another configuration file called query.yaml. This is where you'll want to look at this on your own, but we can look at the actual queries that have been pre-written in to PBNJ, and we're probably going to want to change this. This is just what Josh put together for his, what made sense to him. Here's a really simple query here called machine_audit, and it's just going to select the IP, the host name, and the operating system from the machines table. So if I wanted to change that or maybe add something to it, it would be as simple as adding just the next column here. I don't know if this would work, version, but you just add another column to query against. So pretty straightforward. So I, ahead of time, had already run some Nmap scans. And rather than us sitting here waiting for Nmap to do its thing, I'm sure everybody has run that a number of times. I had to dump out to an XML file, and we're going to go ahead and just import these into our database. So scan PBNJ -X, and we'll run in our first scan results. And boom, we fired in this or added in this system, and IP address. Here's a service that we found running. It's running HTTP. Scans complete. That's really all that we had going. If I want to do output PBNJ to query that data, then if I want to find out -N, yeah. I want to find out the names of all the queries that to run. It's just output PBNJ -N gives me the name of each query. At that point, I can just say, okay, well, output PBNJ all services, and I messed up my syntax. What did I mess up here? Oh, -Q. Output PBNJ -Q, all services, and now we find that we had this web server sitting out there. Unknown version, unknown product. I didn't tell Nmap to really interrogate this system heavily. Let's take a look at service audit. Machine audit. Okay. Not terribly exciting. I only have a single host in here, but at this point I would be dumping out, hey, here are all your live hosts. Now, we're running along and it's time to do the next scan, and we something changed on that host. And our scan picks it up, writes it to the XML file, and we upload it into our database. And now you can see PBNJ has noticed, hey, we had port 80 running on this thing before. It's now down. If I go back to all my query for all of my services, it still records that it had that in there, but it's caught on to the idea that now that has gone offline. We've had a change. We'll run our third scan results. Okay, this time it's discovered, okay, now port 80 is back up, fabulous. The machine's already in the database, it knew about that, but it found an additional port. And the reason why it found a new port is I told it to scan all 65,000 ports instead of just the common defaults. And so we've added this new service in here. Go back and query my services again. Let's see here, yeah. And we see, okay, right, we've got HTTP in 2 instances. Here's the scan times that we saw them. And here's this new service that showed up. Now, like I said, you're going to find that maybe these queries aren't working exactly the way you would want. So you would need to go in and do some editing on that, or write your own queries. Just hook up with a database management tool of your choice and run your own queries against it. You could set up a web front end to pull it off of your MySQL database. But now we're not looking at individual scan results. We've taken all of these scanners out here, set them up to run every single day, push it to one central place, and now I can just sit here and run a query and say, give me what's in my environment right now. What's in my environment today that was not in my environment yesterday or last week? And that's where things start to get really interesting for us, because we can, instead of trying to do all of this analysis and looking through massive amounts of data at each individual item. We can just look for the changes, look for the deltas. What has gone down, what has shown up, and why is that happening? So that's one useful way of scanning actively through our environment and pulling that information out. Once you get into the database, if you don't like the database schema, that's fine. You can go ahead and just pull that out to whatever database format that you would prefer. Now, another thing that we want to look at as we're doing this, I've talked about throwing these systems all over the place with it, putting these scanners out here. We need to think about this a little bit. It's so easy to be sitting there thinking, oh, I just need a new host up here to scan this area. And so we set up a VM, we toss a couple of tools on it, we do what we need to do. We may forget that it's there. We may not go back and maintain it. We really need to step back and think about this and say, hey, we're going to maintain this infrastructure like I was maintaining a web environment when I was a sysadmin. We're going to have rules as to when things get updated, when there are the patches getting deployed out to these systems, when what access defenses do we have on them to protect against access or unauthorized access. I commonly am using some kind of Linux host, so making sure to set up SSH keys or some type of two-factor authentication. Lock the box down. Don't just take a default install and throw it up there with the kitchen sink running on it. Look at what a lot of places are doing in DevOps with centralizing all of their config management using Salt, Puppet, Ansible, Chef, etc. Whatever your deployment system is of choice and configuration management system is, use that. Get your infrastructure, your security infrastructure into that system. Don't let it go out there and turn into this scattered array of one-off boxes that get forgotten or get updated very irregularly, to say the least. Make sure that we have centralized logging going on and being put into place. So architect it out. If we're going to be doing a real operations, security ops operation, we need to make sure that we're setting up a real infrastructure to support that. Now, one of the tools that I really recommend whenever we talk about network security monitoring, doing session captures or network captures or whatever, is Security Onion. It's put together primarily by Doug Burks, but he's got a whole team of folks out there. It's a Linux distribution geared up towards network security monitoring only. And so a lot of the tools that we would need to deploy out to different stretches of our network are all there, packaged up, configured, and ready to go. We have some options. We're going to take a look at a default install of Security Onion, but there are options for, hey, just give me something running ELSA, which is Enterprise Log Search Appliance, or just give me a sensor. I don't want any of the management tools on it. I just need a sensor, and I need it to push that information somewhere else. Need to push out a new configuration, new updates. I can do that centrally. So a lot of the stuff we've been talking about is here built into this distribution, specifically for us doing our monitoring. Now, one thing that I always warn anybody, whenever we talk about pen testing or performing packet captures or password audits or anything like that, you want to get explicit authorization in writing. The last thing you want to do is be doing something that you feel is the right thing for your environment, and then somebody else finds out you were doing it, and now you're potentially looking at losing your job, or they decide you're really malicious and they've called the cops on you because now, hey, this guy is eavesdropping on everything that's happening in our network. He's watching all of my web transactions or whatever, and he did that without authorization. So make sure you get that written. It's not enough to have somebody tell you, yeah, that's okay, go ahead and do it. Make sure that that you have that explicitly set in writing somewhere. It gives you that permission. So there's a couple different apps we'll take a look at. One is called Sguil, which is a real-time management system for IDS events. Snorby is another one that is web-based, less on the real-time, more on analysis after the fact. So I'm going to switch over to my Security Onion VM. Okay. We should have Security Onion up on you guys' screen now. And one of the things that sold me on security, I was using Sguil and Snort and a lot of these tools quite a while ago, before Security Onion came out. And I would find that it took me a ton of time to get this set up. And now here's how we get the same tool set that I was using before, except greatly enhanced, set up in our environment. Really easy. You just come in here, double click setup, prompts us for sudo privileges, and we just tell, yeah, let's go ahead. Yep, we want to go ahead and, well, yeah, we're going to configure our interfaces. It asks us, hey, which one is our management interface? Which one's going to actually have an IP address and that we'll interact with? ETH0. We'll use DHCP for this instance. We'll configure the monitoring interface. The leftover one is ETH1 on this box. Click OK. Yes, make the changes. And go ahead and send this thing off on a reboot. And as simple as that, I've now got, when this thing comes back up, it's going to be monitoring ETH1, looking for, have it in monitor mode. It's going to be in a read-only passive mode that nobody can interact with, and be capturing all of in promiscuous mode. So it'll capture everything, that passes along that interface. Get prompted by Fusion now because, after all, I told it to run in promiscuous mode. Give it just a minute here, almost done. By the way, if anybody has any questions about anything that I'm talking about here, please just drop them out in the chat window. I'm keeping an eye on that. No problem stopping to talk about something that you have a question on that we're dealing with right then. All right. Just about done. We go back into our setup. Yep, we're going to go, and it says, oh, hey, look, I've noticed that the interfaces have already been set up. Do you want us to keep skip the network configuration portion of this? Yes, let's do so. I'm going to do an advanced setup real fast. Okay, this is going to be a standalone deployment because it's going to be both a sensor and a centralized server. But if I was pushing out just a sensor, I could select just a sensor option and point it back to some other server. Username to log in to our various apps. Sets our password. All right. Now I remember I mentioned using pads and prads for session data. That's what we're starting to look at here, alerts from those systems as well as our IDS alerts. How many days we're going to keep data inside of the system, we'll leave that at 30. We're going to keep the defaults, some maintenance tasks. We'll go ahead and use snort, but you got your option here of snort or suricata. I'm going to use emerging threats GPL for my rules because I do not have a code to use for this installation. Okay, here's one we want to pay attention to. Which network interface is the monitoring interface? Obviously ETH1, that's what we set up in the first place during our configuration steps. We're going to enable the IDS. We're going to enable Bro. We're going to enable the ability to pull out EXEs out of our traffic. Enable the HTTP agent, Argus, capture our session data, who's talking to who. Prads for our passive asset discovery. The security onion, because it's doing network security monitoring and it's built up around the idea that Richard Balick proposes, tries to capture as much data as possible. So we can tell it, do full packet capture or not. The reason why we would look at doing things like full packet capture, it's not where we're going to look at this data all the time, but if we see an alert by our IDS, I'm going to turn around and start looking at, okay, what happened at that point? What data would have sent across, sent to my target system? What was sent back from the targeted box? Was the attack successful? What information did they send? It starts adding on a lot of context. My session data allows me to see, okay, here are the conversations going on between these hosts, and let's say I got compromised to see that this host is now talking to, my compromised host is now talking to somebody else abnormal on the network. Without having our session data and our packet captures, we're not going to see that. We're just going to see that there was an IDS event, and then it's up to us to piece all of that together without that data already being recorded. Okay, we're going to max our PCAPs out at 150 megs. Yes, that's fine. Okay, we're going to leave salt off on this one. We're going to enable ELSA, which is our logging engine. With all of that done, gives us a quick summary. It's going to set everything to UTC time. That way, all of our sensors are on the same time zone. We can correlate easily. Set up our IDS, set up ELSA, and away we go. Now, and it starts running OSSEC automatically as well. So as we make configuration changes to our security onion hosts, we're going to get that data back as well. Now, as we're watching this run, excuse me, as we're watching this run, it's going to take just a minute or two. But this is something that when I was setting up Sguil and Snort on my own would take days for me to get all of the dependencies working right and get the configuration of the different services set up so that they can authenticate to each other, that they know where their configuration files are, their data files are, and set up your rule updates like what's happening right now. So I would spend a ton of time going through and setting that up and then maintaining it and keeping it running. And with Security Onion here, this is all just happening right now in just a few minutes for me. Extremely useful. My company, my employer pays me to, well, now they pay me to do pen testing, but when I was an engineer, my employer paid me to monitor the security of our environment. They didn't want me to play systems administrator. So really saved a ton of time here. And really ended up with a system that was working better than what I had on my own. All right, we'll let this run here for just another minute. We've got our rules down, so we should be setting up our databases. Should wrap up pretty quick. Oops, switched to the wrong system. Let's get rid of Kali. All right, is anybody here inside this this webinar, have you used Sguil or Snorby or any apps that we've talked about here inside of Security Onion? Okay. So it looks like a couple of people have used it. We've got some folks who have saying that they set it up, they didn't get a ton of data out of it. Okay, so we've got some basic familiarity with some of the folks here. Looks like a few of us. I tend to run actually Security Onion at home because my wife likes it. Me to be able to come back. She'll ask me, hey, I walked into the computer room, which is off, next to our dining room, but want to make sure to see what our son was doing online. So Security Onion's what I use, capture a lot of that information, so I can go back and see, okay, what websites was he gone to, what information's been exchanged back and forth. Now, it's not going to help me out in the instance of, as far as content, it's not going to help me out with content too much because maybe some things are going to be encrypted, with SSL encryption. But still, it gives me a pretty good idea of what systems he's talking to in a given time frame. So I had a comment here, that's so cool that your wife likes and has an understanding of the tools. She doesn't really have an understanding of the tools. It's more like she knows I do, and okay, you go figure it out, and she sends me off to go query the data and tell her what's going on. But she really likes having that there. Folks set up things like NetNanny or SafeEyes is another one I've heard of to monitor what their kids are doing online, and the kids find a way around them anyway. This allows, the nice thing about capturing this stuff is it's passing across a wire, be it inside of your organization or at home, is, hey, if it crossed through the tap, and if I have it set up right, it's going to catch everything leaving my environment, I'm going to see it. So there's really no getting around that. Yes, Brian. She's the management. I'm the technical guy at the company, at the house. She tells me what to go do, and I go do it. All right. So here's some options that's telling us too, some helpful hints. Sudo SO stat to give you detailed information about what all the services are doing. SO stat -quick guided tour, redacted. This is pretty handy. If you had something you need to send out to a mailing list for some help, run it with the redacted. That way you're not going to share any confidential information about your environment. Okay, some information about where the rules are, where our data files are. That's fabulous. We'll take a look at that here in a moment. And I think we're about done. Yep. All right, we're good. Now, if you want to start getting used to try Security Onion out and test out some of the tools, they've got some samples for us. So if I go over to opt samples, we've got a ton of PCAPs here all ready to go that Doug and team has kindly shipped with Security Onion. Now, some of these I added myself. I think it was actually just the shell shock. That I copied down to here. Anyhow, great. I've got all of this data. I want to see what's going on. So let's try this out a bit. So I'm going to fire up Sguil, which is my real-time console. There it goes. Okay, and it gives me a couple options here. I can monitor just what's going on with my network IDS events and stuff like that. And I can focus just on the changes on side of Security Onion using OSEC, or I can do both. And it's saying that unmonitored right now because nobody's connected to it. So let's go ahead and select both, start Sguil. And this is probably going to be a little hard to read. But we've already got some information that's occurred. OSEC is complaining, saying, hey, we've had some integrity files or checksums change. So we can see that the AppArmor rules for MySQL has changed. So that's good to know if some of our configuration is gone. Here's pads telling us that I've detected some NTP services and DNS. It's coming from 10.10.1.85 going out to this other host. Okay. Curl ran against something, so we had some kind of web client running. Again, 10.1.185, which is our Security Onion install. So that's not terribly exciting right now. Let's get some more interesting data in here. Back over to my terminal. Oops. So TCP replay. Pointed at ETH1. And let's go ahead and do the shell shock PCAP real quick. That should run fairly fast. Exploit.pcap. Get my helpful reminder that I need to be root, so sudo. Now you want to be a little bit careful with TCP replay. That pause was 6 seconds, was only 31 packets being transmitted or read across that interface. Obviously, you could send it a whole lot faster, but TCP replay is going to stick with the timing inside of the PCAP. So if you have a really large PCAP covering a good-sized frame of time, then you need to make sure you're prepared for that. Let's go over and take a look at Sguil now. Okay. Still mostly just some pads events. Oh, we've had a problem with, okay, that's just for our stats file. That shouldn't be an issue. So for some reason, that didn't like it. Let's do SO stat. Sguil's running, OSX up and running, bro. It's doing its thing. Everything's coming back okay. You can see what he means by detailed information. We've got processes flying by here. All right. It looks like this should be good. We still aren't getting our data though. So let's try some more. Sudo TCP replay. we'll let that run for a bit. Well, it's complaining because we're back in time. All right, well, looks like the demo has failed for the day because I'm not getting my events showing up here. Let's see. Maybe Snorby's picking that up. Let's go ahead and log into our web interface for our IDS events. There we go. All right, Chrome complains at us. That's fine. Got a self-signed cert, so it doesn't like that very much. That's fine. For our purposes, must be killing this poor VM. Oh yes, it's very busy. All right, we'll come back to this in a bit. Well, let's move on with our slides. This thing's slammed. All right. So one of the things, now that we've got some infrastructure set up and ready to go and working, we kind of go into this monitoring, analysis / testing phase of things. And in some ways, this is the hard part of operations. In part because once it's up and running, as long as it's not broken, it doesn't scream at us. It doesn't scream that there's a problem. It is something that we get interrupted from all the time. We have projects or meetings that come up that we get pulled off onto. My all-time favorite was to be working away and have sales come up to me and say, hey, I have this due diligence questionnaire from our client, and I need you to get that to me Tuesday, and it's Friday, for example. And, really was just a killer. Because I find myself suddenly, dealing with 50 pages of documentation that I'm working with. So some things that I found that seemed to help with this. One, I tried to go for shorter duration. I had this idea in mind that, hey, I'm going to sit here with my tools up 100% all of the time. And while a SOC can do that, if you're on a member of a security operations center, you're going to be able to sit there and do that kind of monitoring. If you're in my shoes, where there's one or two of you working for the organization, you can't stay sitting there watching this stuff all the time. So I found if I set aside 30 minutes, an hour, something or other a day to just go through what I could and go with consistent short bursts of monitoring and analysis, I started to find all kinds of stuff that I had, that would have been invisible to me otherwise. A couple of things happen. One, at first you're overwhelmed. You've got a huge amount of alerts piled up inside of your IDS. You've got and you've got to sort through that and tune your intrusion detection system and your queries and whatnot to get rid of the noise. Your host integrity monitoring systems, I found that wasn't something that took a while to get going. And what I would do is I would find where the noise was. Hey, this is a common event. It happens a lot, high volume, low value. Let me write a filter for this and then just exclude this. Let me tune my intrusion detection system so that it only comments on it once every X amount of times that the alert fires. Or just suppress the rule entirely. And all of a sudden, things start popping up. One of the things that blew me away, and it was right after I set up Sguil and Snort at my employer. I'm sitting here, get it up and running inside of our office, take a look, and within a couple of days, I started seeing Excel spreadsheets passing over HTTP with no encryption that contained a bunch of loan data in it. It was basically being uploaded into a web application for processing. So, I was looking at stuff like the borrower's name, their address, where they work, their social security number, phone numbers, just really anything you could think of on your mortgage application that's sensitive. That's what I was looking at. And it was like, oh my goodness, we've got a real problem here. Where did this come from? And it turned out that we had a misconfigured web server. The site was set up to do SSL. But if somebody just typed in the domain name for it, it also accepted HTTP, and it didn't redirect them up to use SSL, use HTTPS. And went and talked to the right folks. We got that taken care of. So, once you start using these bursts, you get a feel for that. You start clearing out some of the noise. You get a feel for what's normal. And then all of a sudden, these unusual things start popping up, and you can address those and start responding to that. Okay. Snorby, let me check something here on Snorby. Oops. Yeah, that's not happening there either. All right, my security onion setup went south on me. Apologize, everybody, on that one. Some other things you can also look at doing. One of the things I talk about and I have this maybe here on, not necessarily part of this presentation, but setting up false flags or targets to entice attackers to do something. I'm sure you've heard similar ideas of, hey, look for a request for set up a fake URI inside of robots.txt. And if anybody requests that, they're messing with you, or at least looking at you. Something that's really useful for that is mod security. If you have mod security running inside of your environment, you can actually insert bits of HTML that aren't really valid, that don't do anything, but that it might look interesting to an attacker. And then as soon as they respond to that, then you can alert on it. Helps us separate some of that noise out there. Now, one of the things that we find is that we all have this idea that we want to do pen testing. We want to pen test our environment, and we can never find the time to pen test in our environment. And it's like, oh, I think I'll have a little bit of time. Okay, maybe a little. Sometimes I'll have time. No, I don't have any time for this at all. I'm just getting slammed. So the reality is we rarely do much pen testing. Certainly not, at least my experience. I could not find the time to go through and spend a couple of days going through a web app and hammering away at it. So how did I deal with that? I still need to keep an eye on what's wrong inside of my environment. So this is where some of our vulnerability scanning and vulnerability testing comes into play. We can go ahead and automate that, run it, and see if anything crops up and looks worth following up on with some pen testing to validate a particular issue. We want to do this as often as we can. Things change pretty rapidly. I think people stand up a new system, or here's something happened to one of our clients a couple of times. We go in there and we're scanning with, we use Nessus a lot of times during some of our assessments as part of our scanning. And you look up and you see, hey, here are all your Dell Dracs, and the username and password is root Calvin, the default credentials. And they get this stunned look on their face going, wait, we set that. That was changed. And after they talk to them a little bit, we find out that they had somebody come out to do some service on the systems. They reset the credentials back to the default so that the third-party tech could work on it but not know their actual credentials. And then they never changed them back. So that happens a lot. So that's why I say you want to scan as often as possible, because that can happen, right in the middle of the week. And, if you scan once a month or every 2 weeks, those credentials could be sitting out there, default creds could be sitting out there running for a fairly long period of time. One of the things you want to look at is getting to know your tool set. I'm guilty of this, or was guilty of this, whatever, with Nessus. When I first bought Nessus, I looked at it and said, okay, I had heard from back when Nessus was an open source project that, hey, you had to be really careful with running Nessus inside your environment. It could cause things to crash and knock down. I think I remember one guy saying that he knew somebody who knocked down an entire Class C with a bad scan setup. So I was very hesitant not hesitant, but careful when I got Nessus in my environment. And I think this applies really to anybody with their vulnerability scanner of choice. But they're very worried about causing a system to crash or an application to go offline. That's changed an awful lot. Now when you do a default scan or a safe scan, as they have it set up, they, like Nessus, at least they tell you to use safe checks. As long as you have things set up fairly default, you're going to have a very safe scan. One of the things that I did that was a mistake was I went in and said, okay, well, I'm going to turn off this, and I'm going to turn off this plugin and these plugins over here because it doesn't apply to our environment anyway, or that one sounds kind of risky. And so I got this super customized scan, and I ran it, and I was really happy because I had done all of my tuning, and I was scanning like the big boys or whatever. And I started getting some information about Nessus, and I realized, holy cow, I'm doing this entirely wrong. The tool is written differently. If it doesn't apply to the system, the plugins don't run. In fact, some of the plugins I turned off were dependencies for other plugins that I was interested in. And because of that, I skewed my results. I didn't get accurate data back. I also came up with this idea. If y'all are familiar with vulnerability scanners that you use, you have the ability to put in credentials, do a credentialed scan. And I looked at that and I thought, well, that's cheating. Because that's the bad guy wouldn't have credentials. And as I stepped back, I realized, wait a minute, my job is not to be, as a security engineer, is not necessarily to be a hacker. With my vulnerability scanning, it's to find out what the vulnerabilities are so I can get them fixed. And all of a sudden, if I ran a credentialed scan, I got a lot more information about what was wrong. It was more accurate. because instead of throwing the kitchen sink at whatever network services were available in that target, Nessus logged in, ran a few commands, got the information, got out, told me exactly what was going on. Now you still can get some false positives from any scanner, but it was a very safe scan at that point, and it makes sense for trying to manage vulnerabilities in my organization. So I always recommend to anybody, regardless of what tools you're using, take advantage of the information that's out there. There is, with YouTube, it's not unusual at all. You go to the vendor's YouTube channel, and they've got how-tos posted there. And they may not be as in-depth as a full 2-day class on Nexpose, but you're going to find some key things to take away and apply to your environment. So take a look at that. Look for other YouTube videos put out by other folks who are talking about things that they've learned. Adrian Crenshaw, aka Iron Geek, has a huge amount of videos that he's put out on various tools and techniques. So you want to look for that. Learn from other people, who, like me, made mistakes, found out that I was doing it wrong, and then made some corrections. With our scanning, we want to look at, okay, how long are we going to let go in between our scans? What type of scans are we going to run? We're going to run a discovery scan. Is it going to be a vulnerability scan? Is this going to be a compliance scan? And when should each of these occur? Compliance scans probably not going to occur very often. I'm going to do that maybe once a month or so, when it's appropriate to look for, make sure that my configuration or whatever that I'm auditing against is in line with whatever baseline I've configured. Vulnerability scan, okay, that I want to scan more often. Discovery scans, probably ought to run discovery scans every day. Now, there's some caveats with that that I mentioned earlier. Vulnerability scanners, depending on what you've purchased, has limitations on the number of IP addresses you can do that with. So you want to make sure that you're not killing all of your licensing because you fired it off at too big of a block of a network on a given scanner. So when I say discovery scans here, maybe this is where we're going to push it off to Nmap, grab our live systems, and then we'll pump that into a vulnerability scan. When you get started, expect to be overwhelmed at first, particularly the first time you run a credentialed scan. You'll get a ton of information back, and at first it's overwhelming. You need to step back a little bit and say, okay, what's important here? Let me go for this subset. And again, we're back to that short duration, focus on a subset at a time and chip away at things, and that starts getting down to a manageable level. Expect to take some time on that. You do want to go in and validate some of obviously the flaws that it's reporting. We see it all the time. Run your vulnerability scanner. It starts complaining back, telling you that you've got cross-site scripting on this site. You go look at the output, and you find out, yeah, that's not cross-site scripting. It's a false positive. So you want to double check that before you start running out there and open up tickets to get things fixed. Now, if your environment is anything like places that I've worked, you're going to find some flaws that you've gone in, you found them, you validated it, and I can tell you that this is a high severity issue because I found SQL injection in this web application. And I try and explain that verbally. And it makes no impact on the person at all. They don't care. They don't really understand what I'm talking about. SQL inject something. What do you mean? What is that about? And so you really need to figure out how to test this issue and do so in a way that provides the impact necessary to give you the ammunition to get it fixed. Obviously, you don't want to do anything destructive here. Yes, it is high impact when you drop the tables in this database. It's also what most folks would consider a resume generating event. You have to start sending your resume out to find a new job. So take a look at your vulnerability data. Pick an area to focus on that you're really concerned with, and start digging into it. One of the things that we'll get sometimes from some of our clients, we need to do pen testing. We need to pull in secure ideas to do a pen test. We need to pull in a third party to do this. Well, not necessarily. You can go ahead and do this yourself. Pick an area, just because I don't have time as a security engineer to spend 2 days focusing on this app, I can still pull out one piece and do some pen testing against this particular area of vulnerability inside this app. So you can do that. Maybe it takes some time to get spun up, but don't necessarily look out there for a third party to do that. But you do want to be ready to document it well, exactly the steps that it takes to reproduce the flaw and the things that you can do with it. Just coming back and saying, boom, I got shell on this system, isn't necessarily going to mean anything. It still looks like voodoo to them. So you want to have something where it's just step by step, boom, boom, boom. Here's how I got to this point, and here's what I can do with it. All right. When we talk about pen testing, this may or may not apply to you guys. There's a little bit of method to our madness. We talk about doing reconnaissance. If you're the internal guy, you're probably not going to be doing much reconnaissance. You probably know a lot of this information, but it can still be useful to see what's leaked out there. Mapping, you probably know how to use the target application or system because you're required to do that. But sometimes we need to spend some time here to figure out, hey, just how does this web app flow through? And then, discovery, that's our vulnerability scanning, or we've spent a few minutes digging at the app, looking for maybe some cross-site scripting or what have you. Once we've got something, though, where we found an exploit, like I said, we've popped shell on this box, or we've got SQL injection going. What we're trying to do is demonstrate the impact of this. So who's your audience? What's important to them? As sysadmin, what was important to me may not be the same thing to someone else in business. Shockingly, sometimes I would, get really excited because, oh my goodness, somebody can get in here and start dumping all of this data out. Here's this application that's processing credit cards and it's dumping confidential information out of it. This is horrible. You go to your execs and you started explaining this, and they look at you and they say, okay, well, that sounds bad. We need to get that fixed, but we got to juggle that with this and this and the other, and you start getting pushed down the priority chain. Okay, really, what's important to the CEO? Look, if we don't get this fixed and it gets discovered, it's going to cost a huge amount of money to fix, and the payment processor very well may shut down our ability to pass credit cards. There goes our revenue stream. Oh, that's important. Goodness, we need to get that on that right now, and it becomes their first priority because they don't want to get shut down. You don't want to get bogged down into the details of all the technical steps of this. I used to do this for fun, actually. I had a VP of sales that I worked with who worked at this company for about 7 years or so. Anyhow, I would walk by Jeff's office and we'd start chatting a bit, and then I'd start throwing out a few technical terms just for fun. And I'd watch his eyes get big and he'd go deer in the headlights. Well, that's fun for fooling around. definitely not what you want to have happen when you're trying to communicate what's going on with a flaw. So cut the tech speak, get right down to what it means to them. We can get into the technical details later when we're talking to the developers. Now, as we're communicating this, what is the best way to communicate how easy it is to do? Is it just a document that explains what's going on? Maybe some screenshots? Do we do a video of it? We toss something up on the projector. Do it live. As we saw today with my security onion example, the demo gods are mean and cruel and like to pop up and smack us down when we get thinking we've got things pretty well set up. So you want to take that into account. You get up in front of your management and talking to them about the SQL injection flaw, and then it doesn't work as you try and do it live. So maybe this would be an instance where a video would be better off for us. And then that gets us our buy-in. So, or hopefully helps us get our buy-in to go get this issue fixed and get it into the dev queue. But it's something you want to be careful of. But communicate that end result. Don't just, look, I've got command.exe. Well, that doesn't mean anything to me. Look, I just added another administrator count on it, and now I can log in via RDP. Aha, got it. That's visual to them. They understand that you now just took control of that system. Okay. Obviously, web apps are near and dear to Secure Ideas' heart. We do a lot of pen testing of web applications. And as a security engineer and a sysadmin, I would get in systems and appliances and stuff like that. And they all had web front ends, it seemed. We do pen tests, and we run across them all the time, and they're vulnerable to all kinds of issues with Apache or bad configuration that somebody set up on that particular appliance. And I've sat through the vendor meetings as much as I'm sure you guys have, where the sales guy is telling you, yep, this thing is all locked down. There's nothing you need to worry about with it. And then watched one of our security guys poke around at this, actually, oddly enough, a security appliance, and dropped a root shell on it using a JMX extension. Everybody talks about our open source apps. Hey, we got a lot of eyes looking at each of these apps, getting all of the bugs fixed. Well, in some apps that have a lot of following and stuff like that, that's probably more the case. But there are other apps out there, the majority of the apps that are out there, that, it's just a couple of guys like us writing this thing up. And sure enough, they make mistakes too. And it's just one or two people working on this particular system. So we need to take a look at those. And then our in-house developed apps. Sure, if I'm looking at a security web app that somebody's put together, at least the guy who's writing that open source app, he's concerned about security. But if I go talk to my .NET developers, it's not that they're not concerned about security, but they're concerned about, hey, I need to know how this new feature set works. We've got this project that we're trying to get out. Here's the date. They don't spend much time trying to look up different security flaws. Very, very, very rare that you'll find a web app developer looking around to see, let me check out OWASP and see what type of stuff they're talking about and how it applies to my platform. So we're going to have to do some education there. Most often is the case. So you want to be prepared for that. And sometimes it's really handy to go into our QA environment and say, hey, let's take a look, do a lunch and learn. Let's take a look at some stuff inside of our apps, and we'll talk about what I'm able to do when I try to hack the web application. Once they see that, my experience is the developers start getting on board. They want to fix problems, so they start getting on board in a hurry. Oh my goodness. Okay, yeah, you just dumped stuff directly from the database. I want to get that fixed. Common list of flaws everybody I'm sure here has heard about. Cross-site scripting, the ability to run dynamic code on our an attacker to run dynamic code off of our site in a way or inject it and have it run on the browser. cross-site request forgery, where we trick somebody into making a request using their credentials on our behalf. SQL injection, logic flaws are a lot of fun, where we're not necessarily dumping stuff from the database or getting access to the server, but all of a sudden the price of your product went negative and you owe me a big refund. Definitely a fun one to abuse. Our primary tool for web app pen testing is going to be our interception proxies. So things like Burp, Zap, security, as we use Burp Suite a lot. I know some folks that use Zap, and the Z-Attack proxy is very popular as well. Browser extensions are extremely handy. I love using Firebug, particularly if I'm interacting with some site that has an API. I can just jump over into Firebug and watch the interaction with the API in the background. Web developer toolbar for Firefox is always great. And nothing like going in and editing your cookie values in your browser, changing it, and then becoming somebody else in the system. Scripting, like I said, we want to automate. So, break out our Python scripting and get, or whatever it is that you're familiar with and comfortable with, whatever applies to your environment. We taught a class recently, the Tactical SecOps class, over 2 days, and one of the guys, he wanted to know how to get all this into PowerShell. So, whatever it is, but the idea is we're going to make some repeatable scripts so that we can hand this off to other folks and say, here, when you think you've got this fixed, run this script against your app and see how it works. If you get these results, you still have a problem. If not, come let me know, then I'll hammer away at it a little bit, and we can verify that this issue is fixed. Again, we're saving ourselves time here. By being able to do that, we're not getting asked to go fix a flaw that you find out that is actually still vulnerable, and you're wasting your time on that. So get your scripting skills up to level so you can knock that out pretty quick, and it makes a real big difference to be able to hand that power off to QA to validate that, yep, that flaw is done and it's good. Now, I mentioned Burp Suite. Let's go ahead. I'm just going to go ahead and open this up real quick. Let's switch this over. Okay, I'm just going to have to do the screen. So I've got Burp Suite up and running here. We're starting to get low on time here, so I'm not going to spend a ton of time in here, but I wanted to point out some interesting things inside of Burp. Right now I have my Firefox install pointing in here to Burp Suite. If you want to see something interesting, sometimes just open up your browser and see how much chatter is going on. These are all of anything in black here is what Burp has gone out and made a fetch to and pulled down some kind of resource. The rest are links that it's seen. And all I did was open up Firefox and load secureideas.com. So that was kind of interesting to see all the requests to Google and Mozilla. One of the key things you want to look at with your interception proxies with Burp is what's your scope? What are you testing? So one of the first things that we always do, we open up the web, get everything set up, we connect to our target website, and then we're going to right click on that and add it to the scope. In this case, I'm going to add both references, HTTP and HTTPS, to the scope. If I go over to my scope tab, now when I turn on any kind of automated scanning within Burp, it's not going to bleed over into other sites that it shouldn't be touching. It also allows me to come in over here to my proxy and do things like, here, show every request my browser's made Well, that's a little overwhelming, and most of it is to Twitter. So instead, show me only in-scope items. Okay, now we've got down to just a few requests, and it's only on our targeted environment. You do want to watch it. Something I just realized I did. I don't know how long I used Burp before I found out that this big long bar up here is actually a button, and it drops down this filter. So something to keep an eye on for you there. Little quick tip. Now, most of the time, I spend my time in testing here inside of the proxy tab. Go in, make a request. So I'll go over to proposal here. Oops. Here's my web page. That's great. I'm going to go ahead and send an email to. I'll just fill this out real quick. And submit the request. Fabulous. Got sent. All right, now I have this post request up and running. I can see the exact parameters that were sent and do things like, well, let's send this. Let's go ahead and do an active scan, which I'm not going to do at this point. That's not really necessary. But I'm going to send this over to Repeater instead, because I want to play around with this for a little while. And I can mess with it and put in some, let's see, some kind of single quote or whatever. You maybe do an injection attack on something. If it was giving it input back to me, maybe throw in a cross-site scripting attack. And then just tell it to hit go. The request gets made, and I can keep working with that repeatedly and see what the results look like, and without having to go into my browser each time and make these changes. One of the areas that I like to work with a lot as well when you're network pen test or web app pen test, to be honest with you, you'll see things that are encoded. And some folks will get confused on this and say, well, it's base 64 encrypted. No, it's not encrypted. It's just encoding. It looks unusual. We'll go ahead and encode this as base 64. Well, that looks pretty random and pretty crazy, but I'll toss data in here all the time and try some different methods of decoding it. And now I'm back to my original message. Sometimes you'll see apps will do things like, okay, we're going to encode the original value as base 64, then we're going to gzip it, and then you have to come back in here and decode it as such, as gzip, and then decode it again as base 64. Now we're back to our original text. So sometimes we have to chain things together, and Burp allows us to do that really well. Toss in some kind of encoded value in here, or ASCII value characters, and decode those back out to our original values. Sometimes it's really surprising when you see get tossed into cookies or whatever, hidden form fields that they think is protected because it looks rather obscure. Intruders are also a real fabulous tool. I can't say I used it a whole lot when I was doing security engineering, but I can go ahead and I'll use Intruder for things like fuzzing on particular parameters, brute forcing a login field or form, what have you. We've got, we've set up our target, server and port. Here's an example request, and we can fuzz each of these parameters, clear all of those. I just want to focus on this one particular parameter, upload my payload list here, or whatever it is I want to do, and then boom, start my attack. Super powerful tool. We use Burp really for pretty much for all of our pen tests, the bulk of our pen tests, and we'll see things in here, and then we'll break it out and maybe do some scripting and some automation against particular pieces to try and exploit it. But this is where we find and deal with a lot of that during our assessments. Okay, let's go back to PowerPoint here. We've got about 10 minutes left, so I'm going to get through the rest of this pretty quick. I've already touched on quite a bit. Network pen testing. Things have gotten somewhat better. We usually see most environments have patches deployed. Configuration, though, is still a huge problem where we set things up badly. One thing that folks need to keep in mind, though, and I think I made this mistake as well when I was a sysadmin, that system's not that important because all it does is this management component or monitoring server inside of our environment. It's not part of our production app. And I can't tell you how many times the consultants here at Securitas have gone in and popped some unimportant system, was left in that state because it wasn't a big deal, and leveraged that access there to turn around to get into a production environment or to steal credentials. In fact, Nathan, one of our consultants, we were working on a pen test together, and he got into this box. He couldn't get any credentials to the domain, so he started causing antivirus alerts on purpose. Sure enough, a sysadmin logged into it. He grabbed their credentials and then logged into their domain controller, and away we went and started harvesting data out of that environment, getting into all kinds of sections that we shouldn't have been allowed to, give ourselves VPN access to a particular subnet, whatever. So we want to keep those systems in mind. If we've got a critical finding on them, even though it's unimportant, it's still important to get it fixed. We've got to get that taken care of quickly. And pen testing allows us to demonstrate the impact of that. So if you have that inside your environment, you're getting pushback, then I would look around and see, okay, let's demonstrate that and let's show how we can pivot and make our case to get this thing fixed. We want to go ahead and do this testing without credentials. We want to do it with credentials with varying roles. It doesn't make sense to use obviously an admin account for that. But if I'm working at a bank, let's see what a bank teller account can do. They should have limited access. Only these functions or applications inside the environment. But through the magical creep of IT, all of a sudden they have access to maybe a section of SharePoint that they shouldn't be able to read into. We have GPOs that are supposed to prevent certain things from happening, but they don't. They're not working. So try that out. Make sure that that's really what's going on. Metasploit is a powerful, powerful tool for demonstrating the impact of these flaws. And I was hoping to dive into that, but and spend some time here, but we're running low on time left. So one of the other things you want to consider inside of your environment is collecting internal intelligence about what's going on. Look at open file shares or credentialed file shares that just somebody in the domain user's account can get into. We were doing an assessment maybe a year and a half ago where a generic user account, all it had was domain users, actually got into a file share, had access to a file share that had SQL backups with all of their confidential data in it. So we connected to it, copied down a small one, restored it, Yep, sure enough, we could see all of the data, did our screenshots, and to demonstrate what we could do with it. I said, hey, I think you need to change some configuration. And the problem with file shares is they're a beast to keep on top of. So you want to have some kind of scanning to check that regularly, be it with Nmap and using the SMB scripts for your Nessus script, Nmap scripting language or scripting engine, NSE scripts. So you can use that. You can use your vulnerability scanners. You can write your own custom web bots. I can't tell you how many times we logged into some kind of wiki or web portal or SharePoint and find that somebody has started storing passwords to management systems inside of there. And so, do things like write a Python bot to go out and hit your SharePoint portal, do some searches, and let you know if it gets any results back, and then you can go validate those. Also, you want to look at external intel. Is data being dumped out there about your organization? This happened to a friend of mine where I saw something on Twitter pass by about his company. I went and looked on Pastebin. There was a SQL dump. I contacted this friend of mine and said, hey, did you know about this? And he didn't, and they turned around and started, getting the word out and getting things fixed. But they had no idea because they weren't looking for that information. So keep an eye out on that. Maybe, again, write another bot to hit Twitter and search for information about or mentions of your organization and investigate those. All right. The biggest thing with security ops and tactical SecOps, we've got to go out and learn. The field is changing all the time. New technology is coming out or new ways of doing things. Business development gets excited over it. We think it sounds ridiculous. It's just some new fancy way of doing something. We still need to go look at it. We still need to go get experience with it because pretty soon we're going to get asked to defend it. So we need to be prepared for that. We need to be prepared for what the attackers are doing. They're changing in response to things that are going on out there as defenses change. It was mentioned to me yesterday by a friend of mine who works at a shop that's primarily Macintosh, that they're starting to see more malware around Macs. It's more nuisance level type of stuff, but it's starting to happen. So the shift is occurring, whereas you went back 5 years ago, you wouldn't see much of anything. Look to other disciplines and see for ideas that they have ideas for things that we can steal from them. I've been watching, the stuff that's being talked about inside of DevOps an awful lot, because they have ideas about how to do operations faster and automate, and that's exactly what I'm looking at here inside of security ops. How do I automate this? What are some better ways to manage data, to search for data, to consolidate it together, to monitor for different things? So steal as much as you can from these other disciplines. Give credit back to them and say, hey, I got this idea from so-and-so in this presentation that I saw at this conference or video that they did. But, we don't have all of the information inside of security. So, there's a lot to learn from. And most of all, we got into security because it sounded fun. We got into technology a lot of times because it sounded fun. So take the time to learn, take the time to do some, to fool around and do something interesting for yourself. It makes things enjoyable, keeps you refreshed. And, I find for myself, I have to set time aside. I have to schedule it just like it was a meeting. Otherwise, I hit the end of the day and, oh man, I didn't do anything. So make sure to do that. Make sure you're feeding yourself. There are webinars like this one that you can attend. YouTube has a lot of great information on it. Like I said, vendors are always putting up videos about how to use their products. training's getting a bit more inexpensive. You still have to be a little careful about some of the sources. You want to look and decide whether or not this is really giving you valid information. But there's some places that you can get some a little bit more in-depth training without spending $5,000 to go off for a week at a hotel. So keep your eyes out for that, and not necessarily security stuff. Hey, there may be videos on how to do things with Node.js, and sure enough, that's what your developers are working with. So go take a look at that. All right. So we're at the end of this webinar. The main things that as I looked back on it with discovering what's inside of our environment, what do we need to be looking for, and how do we respond to that? One, don't depend on documentation. Get things out there that are running and pulling things back. Documentation's great. It gives us a starting point, but let's face it. If you looked at when a diagram was done, it's probably not within the last 3 months, and your environment has almost certainly changed. So run those inventories, do it often. Centralize the data together into one place where you can do analysis on that. Automate as much as possible. It takes some time to get spun up in our scripting languages to be productive, but once we are, it becomes so much easier to take care of repetitive tasks that we never get to, because they're not screaming like they're down or whatever. And so, we automate that, get that information occurring regularly, and have some computer take care of it for us. And then go back to the idea of, hey, I want to test this system. I can't spend a day on it, though. So test in short bursts. Let me take an hour. Let me take an hour and a half. I'll come back to it in 2 days, or whatever it is, or next week. Or you have it set up, though, on a regular schedule where you keep going at it in just little bits, and you bite away at things and are able to get things fixed bit by bit and make a difference. So with that said, thank you very much for spending a couple hours with me here. Does anybody have any questions? Okay. Doesn't look like it. At least I'm not seeing any questions on there. If you have, okay, I got a question about availability of slides and video. Yes, we recorded this video. I forgot to mention it. We recorded this video. We will be publishing that later to everybody who purchased this webinar, so you can download it after the fact. So be watching for that email. All right. Well, thank you again, everybody, for signing in. If you have any questions, please email me, jason@securideas.com. Be happy to talk shop with you. Thank you very much, and I really appreciate you spending the time with me today. Hope you all have a good remainder of the week and weekend.